Hello again. This is Math 1220 coming to you from the College of DuPage, and the title of this lecture is More About Hypothesis Testing and Confidence Intervals. I also include in this lecture the midterm topics framework, so that's sort of a scope statement. As always, please be an active learner when you watch this video. I'm providing additional information about hypothesis testing. So you really start with a claim, and this is usually a verbal statement of something that you're trying to research. And so you make a claim, and then you do a statistical hypothesis test to see if it's true. Now, a claim is a state of nature, and it's best if you take that claim and express it as a mathematical expression. And then you're going to translate your claim to a hypothesis. And either is going to be the null hypothesis called H0 or the alternative hypothesis, which is called H1. And these represent comprehensive but complementary states of nature. So if H0 is true, H1 is not. If H1 is true, H0 is not. And H0 is always the expression that contains equality. And we'll see examples of this as we go through within the VCM sessions and on some of the videos. So now what you do is then you test H0. So you assume H0 is true and you test it. And you can test this with a tool that we've worked a lot on, and that is confidence intervals. So we will be talking about this technique more than other techniques in this class. So H0 can be tested, and there are two outcomes that can happen. You can reject H0, or you can fail to reject H0. So you test H0, you assume H0 is true, you test it, you reject H0 or you fail to reject H0. And then you must translate this technical conclusion into a conclusion relative to your claim. And sometimes you can make a conclusion and other times you can't. Now, let's do an example, and this is an example from 1954, but it's very similar to one we could have done that is happening in 2021. And in 2021, we would be talking about COVID-19. And in 1954, when I was quite young, I was probably more or less this kid's age, it was polio that we were talking about. So I'll remind you of what happened here. This is kind of a history lesson. In 1954, an experiment was conducted to test the effectiveness of the Salk vaccine as protection against the devastating effects of polio. Approximately 200,000 children were injected with an ineffective salt solution, that's the placebo, and 200,000 other children were injected with the vaccine. The experiment was double-blind because the children being injected didn't know whether they were given the real vaccine or the placebo, and the doctors giving the injections and evaluating the results didn't know either. The results said that only 33 of the 200,000 vaccinated children later developed paralytic polio, whereas 115 of the 200,000 injected with the placebo later developed paralytic polio. Statistical analysis of these and other results led to the conclusion that the Salk vaccine was indeed effective against polio, and we're finding the same thing is true. That's that the vaccines that are emerging are effective against COVID-19. It's a similar kind of analysis. So here's what we do treating this as a hypothesis test. So what we want to do is we make our hypothesis that we want to say the hypothesis is, I think the vaccination is going to be effective. So the claim is that the Salk vaccine has a lower incidence rate than the placebo. And we're going to let S stand for the Salk vaccine proportion. And we will let P stand for the placebo proportion. So you see, the claim is that Salk has a lower incidence rate, so the proportion who get polio from Salk after getting the Salk vaccine is less than the placebo. So the claim becomes the alternative hypothesis. Now, if I say, well, what is the case if S is not less than P? That means that S is greater than or equal to P, and the equality makes this the null hypothesis. So now we're going to use confidence intervals. So we take the data of 33 of 200,000 and we get a confidence interval for the Salk vaccine. This is posted on a number line. And then we go and we develop a placebo confidence interval using the 115 out of 200,000, and we'll get this confidence interval. These are 95% confidence intervals. And you see that this one is lower and does not overlap with this one. So what we're saying is, if we are testing the H0 and saying, well, does it make sense for, is this greater than or equal to this? And we think probably not, because the confidence interval over here, all of it, is less than the entire confidence interval here. So we reject H0. That means we support H1, and we conclude that the Salk vaccine is in fact effective against the vaccination. This is a great example. Now, here is the LSA 6 that is due on Wednesday near noon. And again, there will be problems dealing with this, so make sure that you understand how to do this. So here we have the Titanic disaster. Was in 1914, a ship sank, and it was a tragic event, and many people perished, and they didn't have enough lifeboats. But anyway, these are results of the casualties. So depending on your category of passage, here's first class, second class, third class, and you could be the crew. And these were the number of people that were on board, and these were the number of survivors. So the question is, did your category of passage matter? Did it make a difference? And the claim that I'm making here is claim that the category did matter. And you have to use a hypothesis test to test this claim. And there's a second one. This shows sliced by men, women, boys, and girls, women and children over here, and there's men. There were survival rates that are tallied here. And the claim I want you to investigate here is that we claim that men and not men is women and children is not men, were treated equally. And so you can investigate both of these using confidence intervals. You have to think through the problem and the process, but that's what you need to do. And that's good preparation for the upcoming test. Speaking of the upcoming test, we are on time and on schedule. In our topical outline, or student objectives anyway, we've done parts of analysis interpretation of graphs. We talked about histograms and stem plots and other kinds of things, box plots, box and whisker plots. So we've talked about those kind of things here. We've talked about descriptive statistics, collecting and describing data. We talked about correlation and regression. We talked about normal distributions. There are a couple of great problems there. And we've done confidence intervals for proportions and means. And we've also talked about hypothesis testing. So these are those. We also have a topical outline, and it's similar as we've talked about inferential statistics, application problems using normal distributions, descriptive statistics, and some graph work. So that's what we've completed, and we're in good shape. These are the topics I plan to test you on the midterm. There's going to be data where you're taking a file, and you'll find means, medians, modes, standard deviations, z-scores, quartiles, interquartile ranges, things like that, and I expect you to be able to use Excel to do that. Similarly, we will have data, and then you will do regression analysis on this. So we'll talk about correlation coefficients, we'll talk about coefficient of determination, we'll talk about linear regression line determination and applications of that, and even the discussion of does a linear relationship exist or not, and those can use Excel. We do normal distributions, use Excel and tables for this. There were two great problems. Given the number, find the probabilities, and given the probabilities, find the numbers. So those are in play. We've talked about confidence intervals, and we use tables for those. We've done confidence intervals for means and proportions, and those were using Excel. And we've also talked about hypothesis testing using confidence intervals and a little bit of graph interpretation. So this is the scope for the midterm that is coming up, and more about that later. But for now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. May God bless you all.